Hi folks, this is a worked solution video for the kinetic energy questions. Don't feel like you've got to watch the entire video. You can skip through to just the questions that you might have struggled with. Okay, so this first one, you're looking at the kinetic energies of two separate objects. So you've got this bullet and a drone. Ultimately the question is asking how many times larger is it? How many times larger is whichever of these two kinetic energies is the greater. So you've got to calculate both and then divide one by the other, or see how many times you need to multiply one to make it the other one. So you've got the kinetic energy of the bullet, which is going to be half times its mass multiplied by its velocity squared, and the kinetic energy of the drone, which again half times its mass times its velocity squared. Those are the two calculations that you need to do. Note that the mass in both cases is already in kilograms, so you don't need to do any conversions there. I mean, just by looking, you should be able to see that the kinetic energy of the bullet is going to be a lot greater, because 500 squared is going to make that an absolutely massive number, whereas 5 squared is just quite small. And I think it's something like 6,250 and 62.5, so the answer is C, 10 times larger. Right. So this next one, you are looking at the same idea, but you're rearranging the equation this time. So we've not got a mass. So we have a mass, we've not got the velocity, but we're given the kinetic energy to start off with. It's always useful in these questions to rewrite the equation for yourself. So you've got kinetic energy equals half mv squared. Now your kinetic energy you are given is 340,480 equals half times 665 times v squared. So if you double both sides of the equation, so you've got your left side and your right side. On the right, we've got this bit here, this half. So if we double this side, that's just going to vanish. And if you double the left-hand side of the equation, you're going to get what? 68,960. 1,960. Just check that. 340. Yeah, 68,960 equals 665 times v squared. So now you need to divide by 665. That gives you 1,024 equals v squared. Therefore, v must equal the square root of 1,024, which I think is 32. Let's check. Square root answer. Yeah, 32. 32 meters per second. Right then. So this one is a little bit sneaky now. Hopefully you should straight away be able to spot that the mass, we're going to need to do something else with that. That mass is not in a format that we can use it straight away because it is in grams. So 40 grams equals 0.04 kilograms. Hummingbird flies in a straight line between two flowers 18 meters apart in a time of 12 seconds. Now we're doing kinetic energy here, and it's asking us to find the kinetic energy. We never use meters or seconds in the kinetic energy equation. It's mass and velocity. But we don't have a velocity in the question. You need to kind of think, okay, how can I figure out a velocity? Well, I've got a distance and I've got a time taken to travel through that distance. So I can do speed equals distance over time. In this case, speed and velocity are pretty much interchangeable. So you've got speed equals distance divided by time equals 18 divided by 12, which is going to equal 1.5. We've got our mass in kilograms here, so our kinetic energy is going to equal half times 0.04 times 1.5 squared. And that equals, what was really question 3? 0.045 joules. Do remember to put in your units, folks. Right then, next. Object of 75 joules kinetic energy and mass 1.5 kilograms. What is the velocity? So again, we're looking at rearranging the equation. We've started off with being given the kinetic energy, which is more often the thing we're trying to find out. So we've got 75 joules of kinetic energy equals half times 1.5 times the velocity squared. So again, multiply by 2 on both sides to get rid of that half. So you get 150 equals 1.5 times v squared. Divide by 1.5. That's going to give you 100 equals v squared. So v equals 10, which is E. Object of 9 joules kinetic energy moving at 3 meters per second. What is the mass? So this is a little bit easier than previous ones because we're not having to do that square root. We're being asked to find the mass rather than the velocity. So in this one, we've got 9 equals a half times m times 3 squared. 3 squared is 9, so you can just divide it by 9 on both sides, so you get 1 equals a half times m, multiply both sides by 2, 2 equals m. And that'll be in kilograms, so B. Question 6. Object with a mass of 1.25 kilograms and velocity of 12 meters per second. Object's kinetic energy. This one should be pretty easy for you by now. 12 times 12 is going to be 144. Multiply it by 1.25. Multiply it by a half. Or divide it by 2. And you're going to get 90 joules. Next one. We've got almost like an information overload on this one, but what you can do is use it to check that what you're doing is correct. So we start off with object's kinetic energy as it moves at different velocities. What is the object's mass in grams? Now the object's mass isn't going to change, so if you take pairs of information from this table, you should get the same answer every single time. So if we just take, let's say 2.5 equals half m 5 squared. So I've taken this information here. 5 squared is 25. Divide both sides by 25, you're going to get 0.1 equals a half m. Multiply both sides by 2, 0.2 equals m. So 0.2 0.2 kilograms. Careful with that. because you might just jump straight in and go, oh, there you go, it's 0.2, but it's 0.2 kilograms, because both of these values are in our standard units. So if it's 0.2 kilograms, then it is 200 grams. We can check that if we do it with the kinetic energy, the next one down. So do it with 1.6 and 4. 1.6 equals half m4 squared. 4 squared is 16. Divide both sides by 16, you get 0.1 equals a half m. Multiplied by 2, 0.2 equals m. So both of those answers agree with each other. So we're pretty sure we've done the right thing. But yeah, do be careful with that, particularly with multi-guess, multiple choice questions. They don't just put random numbers for the wrong answers. They are quite often going to be popular wrong answers. So 0.2 grams, sometimes you panic and just go, I just want to stop doing this now. That looks like an answer that I've got, I'll stop. But just an extra couple of seconds thinking is going to tell you that that's 200 grams, not 0.2 grams. This one's easy, just looking at which is the correct form of the equation. And that's d, half mv squared. Motorcycle has a mass of 250 kilograms moving at 32 meters per second, has 4 times as much kinetic energy as a 640 kilogram mass car. What's the velocity of the car? This is a pretty tough question because you've got to go forwards then backwards again. This would be worth quite a lot of marks in an exam if they asked it to you like this. More probably they might ask it to you in little chunks, getting you to do it one step at a time. So we have a motorcycle of mass 250 kilograms moving at 32 meters per second, and it's got 4 times as much kinetic energy as a 640 kilogram mass car. Okay, so kinetic energy motorcycle equals half times 250 times 32 squared. That's going to equal 128,000 joules. It tells us that the motorcycle's got 4 times as much kinetic energy as the car. So if we divide that by 4, the kinetic energy of the car equals 32,000 joules. The mass of the car is 640 kilograms. So if we've got 32,000, it's going to be equal to half times 640 times v squared. You can do this pretty quickly actually. 32,000, so we've got a half times 640, half times 640 is 320, divide them both sides by 320, then you get 100 equals v squared, so v must equal 10 meters per second.